Hi, class. Today we're going to go ahead and cover section 4.3, which deals with congruent triangles. There's two warm-up activities here on the board. I have the solutions covered. Maybe if you'd like, hit pause for a second and try to complete these on your own, and then I'll reveal the answers here in just a second. Okay, the solution for number one, if you take a look, is angle K must be congruent to angle L by the third angles theorem, because once you have two angles congruent to two angles congruent from one triangle, congruent to two angles of another triangle, the third angles must be congruent. And the second example, there is the solution there. What we have is an exterior angle shown right here, and it's equal to the sum of this remote interior angle along with this remote interior angle. So hopefully those are pretty easy. Now, getting into today's lesson with section 4.3, a little bit of background information. Congruent figures are figures that have the same size and the same shape. They're identical figures. Now, the corresponding angles and the corresponding sides, those are sides and angles that are in the same position in polygons with an equal number of sides. Consecutive vertices are two vertices that are the endpoints of a side. We'll talk more about that in a little bit here. And then with congruent polygons, corresponding angles are congruent. Remember, corresponding simply means the ones that match up, and the corresponding sides are also congruent. So, with that in mind, we're going to learn we're going to talk about naming polygons here. And what you do is you simply write the vertices in consecutive order. And I'll show you what I mean by that. There's a couple examples, but I think doing example one will help clarify things right off the bat. They're giving you two triangles. They're telling you they're congruent, and they want you to identify all pairs of congruent and corresponding parts, or congruent corresponding parts. So if that's the case, there's actually 6 parts that are congruent. And the order of the triangles that are stated here is super important. Since angle P, or vertex P, comes first and vertex S comes first, that means that angle P is congruent to angle S. And then Q and T are the next one, so that means they're also congruent to each other. Followed by angle R and angle W. They would have to be congruent as well. So that takes care of the congruent corresponding angles. And then as far as the sides go, we'll do that in a different color here. If you look at the first 2 letters of the first triangle and the first 2 letters of the second triangle, that indicates what the corresponding sides are. So we know that side PQ is congruent to side ST. And then looking at the last 2 letters, we have side QR would be congruent to side TW. And finally, looking at the first and third letters, we have side PR, which would be congruent to side SW. So it's super important the sequence of those letters because they indicate which sides and which angles and which parts all match up or correspond. All right, keeping that in mind, there's another example we're going to take a look at here. They're telling us the 2 triangles are congruent. Okay, they're asking us to find the value in x. And actually, you probably know how to do this already. If you take a look, we essentially have a linear pair right here. Okay, and you know they have to add up to 90 degrees. So if this angle is 90 degrees, you know that the other angle, the 2x minus 16, also has to add up to 90, or also has to be equal to 90 degrees. So a quick little calculation will show that x must be equal to 53. So hopefully that problem is pretty easy to do. Using the same diagram now, they're going to ask you a second question. They now want you to find the measure of angle DBC. So angle DBC looks like right here. They're talking about that angle. Okay. So a couple ways of approaching it. Since you know the triangles are equal to each other, angle DBC would be the same as this angle right here. They're congruent because the parts indicate that from that statement. So essentially, since we figured out that in the previous problem, x was equal to 53, we can substitute 53 into here. And to find that angle measure, I'm going to do 2 times 53, which is 106. Subtract the 16 from it, and it's 90 degrees. which again, we knew that was just kind of verifying that our answer was correct. But looking at this entire triangle now, we know the three angles add up to 180. So we know the one angle is 90, which we just figured out, or pretty much knew already. The second angle was 49.3, but we have that unknown angle, and the three of these together have to add up to 180. So we do some simple little math, simplifying that side and subtracting the 119.3 from both sides. We get x is equal to 60.7, I believe, if my math is correct. And actually, I just caught a quick little error. Notice this should be 139.3. So what I explained to you is correct. Over a quick little mathematical error. Correct answer is 40.7. Sorry about that. All right, moving on now. We're going to go ahead and take a look at 4 different proofs. Okay. What I'm going to do is go ahead and kind of explain as we go, but I would say if you want, maybe hit pause, think about what you're trying to do on these proofs, and if you look, they're trying to get us to prove that triangles are congruent in all 4 of these examples. So that essentially means we have to get all 6 parts congruent in the 2 triangles, in the 3 sets of angles and the 3 sets of sides. Now keep in mind, really we only need to get 2 pairs of angles congruent because we can use the third angles theorem as our third set of angles. So with that in mind, let's kind of go ahead and go through this somewhat quickly. We have some given information here. Angle YWX and angle YWZ are right angles. That was given to us. So there's one pair of angles. By the right angles theorem, we know they're going to be congruent. That's why I went ahead and labeled the diagram. Looking at our next piece of information, it says that segment YW bisects angle XYZ. Okay? So if it bisects it, that means it's splitting it in half, meaning these 2 angles are congruent to each other. So there's another one of the 6 parts we need. We have some more given information that W is the midpoint of XZ. Well, based on that, we know that these 2 segments must be congruent. I guess I can put 1 slash there, 1 tick mark. And continuing to move on, we're looking for some more parts that are congruent, so we can use the reflexive property to state that those 2 sides are congruent to each other. So we're getting pretty close here. We are given some more information that side XY is congruent to side YZ. So looking at the diagram, I can see we have 3 sides congruent to 3 sides. We already have 2 angles congruent to 2 angles. And again, by the third angles theorem, we can say that the third set of angles is congruent as well, meaning we can finally say that 2 triangles are congruent based off the definition of congruent triangles. Now, each of the next 3 examples are going to be pretty similar in nature. What we're trying to do is trying, again, to get all 6 parts of the one triangle congruent to all 6 parts of the other. So I'll go ahead and do this next one here. Again, we'll reveal the given information. And we'll take one piece at a time as far as the given information goes. It said that AD bisects BE. So based off of that information, we know that segment BC would be congruent to segment CE. And that's based off the definition of a segment bisector. And we have another very similar statement. BE bisects AD. It's the same as statement 1, but just kind of flipping it around. They're bisecting each other, which means these 2 sides are congruent to one another. They gave us some additional information. They already had it marked on the diagram, but I'm going to put a third tick mark there because we already used the 1 tick mark. So we already have the 3 sides congruent to the 3 sides. Now we need to work on the 3 angles. Well, they gave us one pair of the angles, and it was indicated. Angle A is congruent to angle D. We can always use the idea of vertical angles. So first we must say that they exist based off the definition, and then we can say that they're congruent because that's what the vertical angle theorem tells us. Now that we have 2 angles congruent to 2 angles, we can say the third set of angles is congruent. And once again, that's based off the third angles theorem. And now we can ultimately say the triangles are congruent because we have all 6 parts congruent to all 6 parts. So with these last 2, I'm going to basically do it the same way, but you might want to look at them real quickly, see if you can figure out how to do them on your own, maybe even go ahead and try them on your own. And I'm going to go ahead and reveal them as I did these previous 2. Now keep in mind, these can be done in a different order, and sometimes they can maybe be done differently than what I'm showing here. A lot of times with proofs, there's multiple ways of doing it. But let's go and do this third proof now. They gave us kind of a different diagram over here, so I'm going to have to review a couple things at a time. But they said that MK bisects JL, so that means that we could say segment JN is congruent to segment NL. So there's JN, and there's NL, so we know those two are congruent. We have some more information about bisecting, segment bisectors. So we have segment MN is congruent to segment NK. Let's see what else we have to work with here. They told us that segment JK is congruent to segment ML. Actually, there should be little lines above there. So JK, what do we have there? Congruent to segment ML. So we have three sides of one triangle congruent to three sides of another. Now they told us the lines are parallel. So instantly, as soon as we see that we have parallel lines, JK is up here and ML is up here. Instantly, you need to think about things like alternate interior angles and alternate exterior angles, and it turns out that's what I'm going to use. Angle KJN, it's a little cluttered here, would be congruent to angle MLN because of alternate interior angles. And we can do the same thing with a second pair of angles. And I apologize for the clutter there. So we just have one more pair of angles to get, and if you look at them, we actually have a set of vertical angles right here in the middle. And that would say that would now give us the fact that all three sides are congruent to all three sides, and all three angles are congruent to all three angles. So we can now state that those two triangles are congruent. And then finally, the last proof, again, if you want to try it on your own, it's up to you. But here it is, and once again, we're trying to prove that two triangles are congruent, so I'm going to go a little bit more quickly. We're given the fact that they bisect each other, those two segments. So right off the bat, I can go ahead and do some labeling here. I know those two segments are congruent, and those two segments are congruent. We have some more given information. Angle PQS is congruent to angle RTS. We are told that two more segments are congruent here. So we have the three sides congruent to the three sides. We need to continue to work on the angles here. And once again, we have some vertical angles that we can show are congruent. And then, again, since we have two angles congruent to two angles, we know the third angles are going to be congruent as well by the third angles theorem. And if you look at my cluttered diagram there, you can see that we do have 6 parts of the one triangle congruent to the 6 parts of the other triangle. So we can go ahead and say that those triangles are in fact congruent now because of the definition of congruent triangles. Now that pretty much wraps things up. Your homework for tonight is right here. It's the same that's on your agenda that I've given you and on the homework board. If you need to, go back and study those proofs, but hopefully those 4 proofs were good enough to give you a good head start with tonight's homework. Any questions you have or any trouble you have, I'll be happy to help you when I get back on Tuesday, okay? Thank you, and good luck with your homework.